What's 3i Atlas's next move? Let's check out the data to find out. I'm Dr. Amanda Fetch, aka Dr. Amanda Analytics, and I'm excited to share an update with you on 3i Atlas. Right now we're in a solar maximum. The sun is firing off solar flares and coronal mass ejections, and we're feeling it on Earth as geomagnetic storms and auroras can be seen. And at the same time, quietly in the middle of that activity, an interstellar comet, 3i Atlas, is already on its way out of the solar system. And so in this video, I'm going to use real live NASA JPL Horizons data for 3i Atlas to show how it rounded the sun at the end of October and is now escaping into interstellar space, and how this connects to my research on anomaly detection, space situational awareness, and orbital debris. And so to understand this story, we have to start with the orbital data from NASA's JPL Horizons system. So Atlas has an eccentricity of about 6.14, a perihelion distance of 1.36 astronomical units, and a negative semi-major axis. Perihelion occurred on October 29, 2025 around midday, which is when it made its closest approach to the sun. And so to give some context here, most comets have eccentricities just under around a 1, and once that eccentricity goes above a 1, the orbit becomes hyperbolic, and it's unbound, meaning the object isn't gravitationally tied to the sun anymore. And so from the orbital elements alone, Atlas is dynamically interstellar in the same family as Mau and Borisov. I used the Horizons web app and selected vector table so I could get the comet's exact position and speed each day. And so I set the coordinates center to the solar system barycenter, essentially the sun's gravitational center. So the distances reflect how far Atlas is from the sun, not Earth. And so I used a time frame from October 29th to December 17th with a one-day step, which gave me a smooth day-by-day view of its outbound motion. Horizons inputs a few important numbers. One is RG. So RG is the comet's distance from the sun's center of mass in kilometers. RR is the radial velocity, and it's basically how fast it's moving directly outward or inward in kilometers per second. Now, to make those distances easier to understand, I convert them into astronomical units using NASA's standard value, which 1 AU is about 149,597,870.7 kilometers. So the astronomical units would be the RG value divided by that 1 AU value, which would yield us our calculation, which I'll get to momentarily here. So on October 29th, the perihelion horizon gave us an RG of approximately 2.04, and we multiply that by 10 to the 8th power of kilometers, and we get approximately 1.36 AU. Now the RR is approximately negative 1.0 kilometers per second, still slightly inbound, and this is the point where Atlas swings around the sun. Now, if I jump to today, November 17th, the Horizons table shows an RG of about 2.27. We multiply that by 10 to the 8th kilometers, and then we get approximately 1.52 astronomical units, RR approximately plus 27.9 kilometers per second, which is strongly outbound. So in just 19 days, Atlas moved from 1.36 AU to 1.52 AU and flipped from slightly inbound to almost 28 kilometers per second outward. And so if we extend that same ephemeris forward 30 days to December 17th, Horizon predicts an RG of about 3.32 times 10 to the 8 kilometers, which is about 2.22 AUs. RR is about 49 kilometers per second outward. So from November 17th to December 17th, Atlas gained roughly 105 million kilometers in just 1 month. That's about 3.5 million kilometers per day, which is exactly what an interstellar escape would look like. And so that pattern, which is steadily increasing in distance, rising outward speed in a hyperbolic orbit, tells us Atlas isn't coming back. So the sun can't slow it down enough to recapture it. So Atlas will pass the outer planets, move beyond the heliosphere, and go back into interstellar space. And all of this is happening during a solar maximum, when the sun is producing more flares, coronal mass ejections, comet is moving through a turbulent heliosphere, which makes its motion even more interesting to study. And so in my AI and space situational awareness work, including my dissertation where I used DBSCAN, I used anomaly detection to flag unusual orbital behaviors. Atlas stood out immediately, with that eccentricity value of around a 6.14, negative semi-major axis, rapid outward acceleration, tens of millions of kilometers gained in weeks, is the definition of an orbital outlier. And the same techniques that identify interstellar objects can also detect unusual debris motion or unexpected space weather activity. And so to wrap this up, from its orbital elements to its day-by-day state vectors, everything about 3i Atlas pretty much says it's an interstellar visitor on the way out of our solar system. Now, in just a few weeks, it moved millions of kilometers farther from the sun, and its radial velocity climbs from negative to nearly 50 kilometers per second, and its distance curve shows a clean, continuous outbound trajectory. If you'd like to see more breakdowns combining AI anomaly detection, solar storms, and interstellar visitors, hit like, subscribe, and tell me what you want to see more of and explore, and I'd be more than happy to do a video towards that path. Thank you.